Chapter 6, Neutralizing the Threat of Acid Rain, Part 3. In this lecture, we're going to again review a little bit about the release of sulfur dioxide in the combustion of coal. We'll also talk about nitrogen oxides in the combustion of gasoline, the nitrogen cycle. We'll talk a little bit about the increase in SOx and NOx, as well as going into a little more depth on acid deposition and its effect on materials, as well as human health and damage to our lakes and streams. So again, we talked about in the last lecture, sulfur dioxide is a result of coal-fired electric power plants and other industrial uses. For example, in Allegheny County in western Pennsylvania, in 1990, it led the U.S. in the concentration of CO2, and this was largely due to the concentration of coal-related industries. And remember, more specifically, how does sulfur get into the atmosphere due to this combustion? Well, it has to do with the composition of coal. It's not pure carbon. It contains sulfur as well as some oxygen and nitrogen. Even though it's only 1 to 3% sulfur, if you think about the millions of tons that are used every year, that becomes a lot more significant. And we talked about in this last lecture, it's this sulfur trioxide that reacts with water to form our sulfuric acid, which acidifies the rain. NOx as well, we saw in past lectures, such as Chapter 1, that it can be produced during combustion of fossil fuels. Particularly heavy automobile traffic will lead to spikes in NOx production. Los Angeles County has some of the highest NOx in the United States. That NOx then reacts further to form nitric acid. Let's take a look at the nitrogen cycle. The nitrogen cycle involves the use of nitrogen in the atmosphere by plants and how it cycles back out of plants and the earth back into the atmosphere. Now, if we shift that balance of nitrogen used by plants and subsequent release into the atmosphere, we're also going to influence the amount of NOx in our atmosphere, or reactive nitrogen. Because our population has increased so significantly, and that's the axis here on the left, the amount of reactive nitrogen has increased concurrently. And this axis here is millions of metric tons. So this green line shows the increase in ammonia production due to the Haber-Bosch cycle. This reaction was developed around the turn of the 20th century. After it was developed, we were able to produce reactive nitrogen on a very large scale, adding more and more of it to the earth. Let's take a look at the effects of acid rain. Iron metal will actually dissolve when exposed to hydrogen ions, and this is going to accelerate the rusting process. These ions that form can then react with oxygen to form rust. This will happen to some degree naturally, but the acid or the acidity of our rain will accelerate the process, leading to significant costs in material damage. We mentioned earlier the effects of acid rain on anything composed of marble or limestone. Those have a large amount of calcium carbonate, just like in the acidification of the ocean, that H+ will cause dissolving of the calcium carbonate. Additionally, aquatic life is particularly vulnerable to changes in pH. Normal aquatic life has a relatively narrow range of pH it can survive at. But if you continue to acidify, particularly lakes and ponds, due to the acid rain, we will see the die-off of many aquatic types of life. We know neutral rain, quote unquote, is around pH 6, and slowly the average acidity of the US, of rain in the US, is becoming lower and lower. Thinker buddy. Acid rain has a deleterious effect on many objects, which contains incorrectly paired objects and the effect that acid rain has on them. A. Marble and granite, related to the solubility of carbonate salts. B. Steel, the increased oxidation reactions. C. The health of human lungs and allergies to gases SO2. And D. Trees, growth reduction and leaf loss. C is correct. When we refer to acid rain, we're not referring to gaseous sulfur dioxide, even though that may have an impact on human lungs. Acid rain is due to the reaction of sulfur dioxide to form sulfur trioxide, and then subsequently sulfuric acid. All of these other paired objects are actual impacts of acid rain. Marble and granite dissolving due to the presence of calcium carbonate in these substances. Steel has a significant amount of iron, and therefore the oxidation of steel increases due to the protons present in the acid rain. And we also talked about and saw in the video how acidity can impact trees and plant life. Thinker buddy question. Which statement concerning the question of acid rain correctly interprets the nature of the problem? Acid rain is a simple problem that can be solved by individual action. B. Somewhat straightforward problem that can be solved by industry alone. C. Somewhat of a complex problem but can be solved simply by banning all cars. D. A complex problem and will require many different individual and collective actions to solve. D is the correct answer. We know that the production of SOx occurs in coal power plants as well as other coal-using industries. Additionally, NOx is produced due to the combustion of fossil fuels, particularly in automobiles. So we need to have a number of solutions in order to address both sides of the industrial production of compounds that form acids and the consumer and automobile related industry that also form molecules that will acidify our rain. This ends the third and final part of the Chapter 6 lectures.